Alrighty, welcome back. Installment number 111. Look at that. Same digit 3 times. I think that's the only time that's going to happen in this entire series. Mathematicians kind of find that stuff a little bit interesting. I don't know why. Okay, so inductive and deductive reasoning, we're still talking about making conjectures in that first unit here. So the same stuff, we're going to look at, remember what we already saw, is that we tried to understand what a conjecture is, how we make them by observing patterns and by observing properties. And how do we understand inductive reasoning, which is the kind of reasoning we use for making our conjectures, by looking at evidence and making a guess. Okay, first one says, which of these things, so which demonstrates using inductive reasoning to justify that squaring an odd integer results in an odd integer? Okay, so let's think about what that means. Squaring an odd integer. So let's just write one over on the side to get our heads around this. So pick an odd integer, I don't know, 7, and square it, and it gives us 49. So it says, which demonstrates using inductive reasoning to justify that squaring an odd integer results in an odd integer. Okay, so let's look at our options now. The first one, wait a minute. These are even integers, 4 and -6. So squaring those is given as even, and that has nothing to do with what we're trying to establish because those are even integers. Okay, let's look at the next one. -3 is an odd integer. They're squaring it, and they got 9, which is odd, so that seems to support our claim or justifies it in some way. 5 squared equals 25. Yep, same idea. So I'm going to make a note that this one looks like the right answer so far. Let's look at these next two. Now they're using some kind of algebra with variables here. Okay, and what we're going to learn in an upcoming section is that when they're doing that, they're not trying to just justify with empirical evidence. They're trying to do some kind of a general proof. But for now, this question just says, which one uses inductive reasoning to justify, which is exactly what we've done already. That can only be this one. So our only answer is B, regardless of what the rest of them are. All right. Use at least 3 examples to make a conjecture about the difference between consecutive perfect squares. Okay, so we got to know what perfect squares are first. So what are our perfect squares? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. Those are our perfect squares. It says use at least 3 examples to make a conjecture about the difference between consecutive perfect squares. So consecutive, okay. So those two would be consecutive, those two would be consecutive, and those two would be consecutive. I guess we've got 3 examples if we use those 3 pairs. So let's see, 4 minus 1. The difference between those 2 consecutive perfect squares is 3. Okay. 9 minus 4. The difference between those two is 5. Let's see, 16 minus 9. And the difference between those two is 7. Okay. So we have to make a conjecture based on these 3 examples right here. What do we notice about the answers that we're getting? Well, they're all odd numbers. Now, when you make a conjecture, that would be a perfectly fine one here for us to say, you know, the difference between consecutive perfect squares is always odd. But if we can make it even stronger, so a stronger conjecture would be the one that tries to go a step further. What else is the same about those numbers that's even more specific than the fact that they're odd? Well, 3, 5, and 7, well, they're all prime numbers. Okay, not only are they odd, but they're prime. So why don't we make our conjecture this? Okay. The difference between consecutive perfect squares, ES, not SE, is always, and that's the idea about a conjecture. Try to make it a general thing. So always an odd prime number. That's a pretty strong conjecture. I don't know if it's true. We don't know if it's true. So if we're going to try to use inductive reasoning to show that it's true, we'd have to check every possible number in the universe, which isn't obviously not possible. So in that case, we wouldn't be able to prove it using inductive reasoning, but that's our conjecture. So remember all the stuff: observation, intuition, patterns, and properties, what we're looking for here, okay? 2 types of, 2 very different and important types of reasoning we're going to see: deductive and inductive. Inductive conjectures, we don't know if they're true or false. They just justify but cannot prove.